Hello, my name is Kevin Newton, and this talk is about the history of parsing Ruby. Back in the early days, Ruby 0.06 in 1994, Matt's released the first version that I could find a changelog entry for. The next version that I have listed on here is Ruby 0.76. It's been a full year, and Matt's is at this point introducing new syntax with its first breaking change. Hashes didn't used to have a literal syntax, and at this point they are called dicts anyway, much like Python. And this version introduces braces, which was a breaking change because arrays used to be created with braces. So at this point they were created with brackets, much like modern Ruby. A year later, 0.95 is released, and there are some interesting things here. The first entry there is about optional parentheses on method calls, and the second entry there is kind of an amusing anecdote that rescue used to be spelled resque, and at this point Matt's is correcting the typo there that has been in there since the beginning. At this point, Ruby is pretty much ready for the 1.x series, and on Christmas of 1996, Matt's releases Ruby 1.0.961225. At this point, the versions aren't semantically versioned, they're versioned after their date. A lot of the changelog entries at this point are making Ruby look more like modern Ruby and less like C++. For instance, the operator here for designating a superclass within class definition is no longer the colon like it is in C++, but it's the less than symbol that we know in today. Also, the keyword continue used to be in Ruby, but it got renamed to next like we know it today. A year later, Matt's releases 1.0971225. At this point, it's adding syntax for singleton classes and then kind of an interesting option to regular expressions. Regular expressions are now getting the options NE and S as optional suffixes, which are kind of first-class encoding support for regular expression literals. This is an interesting point just because other languages at this point don't really have great support for encoding. It's not really first-class in their languages. The next version released after the 1.1 series is Ruby 1.3.0. It's actually not Ruby 1.2.0 because that's released the following day. Ruby 1.3.0 is a developer release, and there are a couple interesting things being added in this version. The else keyword is being added to the begin, rescue, end clauses to execute code whenever an error is not thrown. Additionally, there's the less than dash indentable here docs. Previously, all here docs had to be put into the very leftmost column of the file. And finally, there's the double colon method calls. This is to somewhat delineate between instance methods and class methods, and there's a couple of various styles. At this point, you don't see it too much in modern Ruby. The next day, Ruby.1.2.0 is released with support for here docs, which has been in this do file for a long time, block comments with the equals begin and equals end syntax. The true and false keywords are added for the first time. Before that, they didn't exist. The begin and end hooks, which are somewhat similar to the awk scripting languages. %W, this is a new introduction of word lists, and this is kind of interesting because the %W is new, but it ends up spawning this other number of literals within Ruby in future versions. There's also top-level constant access, which you can, within a nested class or module, you can now access a top-level constant by prefixing with a double colon. And finally, the or equals and equals operators. Moving right along, a year later, Ruby 1.4.0 is released with support for binary number literals, anonymous splats and method definitions without names. String interpolation now works within other string interpolation, and you can now have multi-byte character identifiers. Ruby 1.5 is quickly released after, with compile time support for string concatenation, meaning if you have two bare strings right next to each other, they can be automatically concatenated together before the script is evaluated, which is something that has also been on the to-do list for a long time. Ruby 1.6 is released a year later with support for rescue being used as a modifier, like if, unless, until, and while. At this point, we get to our first project that we're going to talk about that is not a Ruby version. At this point, Dave Thomas and Andy Hunt are writing the Ruby pickaxe book, kind of the seminal text at the time of learning to program Ruby, and still to this day. And they created a project called nodeDump, which at the time Ruby was a tree walker interpreter. It walked the tree and created a human readable format for all of the internals. To my knowledge, this is the first time that an external project has interacted with the internal RubyNode structure and written out something. And this is just spawns a whole bunch of other projects and other interest in this subject. Very quickly thereafter, a project called Ruth, which stands for Ruby Under the Hood, is published, which is also a C extension, also interacts with the node struct, and this time provides a Ruby level method called Ruby Interpreter Parse that allows you to programmatically access the tree nodes. In that same time period, Ruby 1.7 is released, which adds a couple of things to the language. Break and next now accept values for their escaping. %w array literals can now escape spaces, and you can now put rescue in singleton method bodies. At this point, Ruby 1.7, a lot of interest has started picking up in Ruby, and one of the people that gets interested in this starts working on the JRuby project. The JRuby project was taking the Ruby 1.6 and 1.7 code and directly porting it into Java. And they did something that a lot of other projects would end up doing, which is to take the parse.y file, the grammar file from Ruby, and rewrite all of the actions into their target language, in this case, Java. One of the other goals was to rewrite a lot of the standard library in Ruby just so that they didn't have to write so much of it in Java because it currently was all implemented in C. JRuby still exists to this day and is currently working on Ruby 2.6 syntax. They've still got all their stuff going, and it's still under active development. At this time, one of the more interesting projects, Ripper, is also being created. This is, at the time, Ruby 1.6 and 1.7. It's an entirely separate project distinct from Ruby core. And what it does is it takes the parse.y file from Ruby and a bunch of the header files and strips out all the actions and rewrites them to dispatch parser events in kind of a streaming parser style. It's still using Bison to as a parser generator. And in the documentation, it says Ripper is still early alpha version. If you go into the documentation for Ripper today, you will actually still see Ripper is still early alpha version, even though it's used for a whole bunch of projects that are using it internally to access the parse tree. The next project I wanted to mention was MetaRuby, which was not really a project that involved parsing Ruby, but had some interesting tangential properties to it. It was a project that was very early, far before Rubinius, that was working on implementing Ruby in Ruby. And one of the things that they published in 0.7.0 was a schema for Ruby abstract syntax trees. So this was very similar to like an XSLT for validating XML. And I mention it only because having a well-defined schema for the abstract syntax tree was mentioned by a couple of these other projects as they were going about implementing Ruby in other ways. Finally, in 2003, Ruby 1.8.0 is released. Capital %W word lists are introduced, which allow interpolating into the members of the word list, dynamic symbols, nested constant assignment. Ruby 1.8 is kind of the last holdout before Yarv is introduced. It's kind of the end of a very long era that is the beginning stages of Ruby as we know it today. Finally, there are two projects that are introduced right before 1.9 is released, and they are Parse Tree, which is a project by Ryan Davis, which goes into the Ruby 1.8 internals, and it's a C extension, much like nodeDump and the other projects of this era, and builds out S expressions from the node structs to programmatically access it. Ryan then goes on to build a whole bunch of tools on top of this, and this is the start of other tools introspecting on an abstract syntax tree and then using that information to add to development tools for developers. RubyNode is a very similar project that also gets created at this time, and it's pretty similar to Parse Tree, except that it does things slightly differently in that it does slightly less parsing, slightly less normalizing, and mostly just returns the structure of the actual node structs underneath. At this time, before YARV has fully been introduced, there are a whole bunch of other projects that are starting to implement Ruby. It's a very exciting time for Ruby implementers everywhere. And one of these projects is Rubinius. Evan Phoenix, at the time Evan Webb, is working on a reentrant parser when he's trying to introduce native thread support into Ruby. He calls it Sydney, and part of this project, he is interested in building a bytecode interpreter. So he builds a bytecode interpreter in Ruby using the Sydney parser and ends up rewriting the parse.y file from Ruby and starting to build a lot of the standard library in Ruby. He ends up calling this project Rubinius, and Rubinius lasts for many years. To this day, it still exists as a language platform. It's not exactly a Ruby implementation anymore. It's kind of different. But at the time, this is a very influential project and starts pushing a lot of the bounds of what we think of as Ruby. At the time, Cardinal is also introduced, which is a reimplementation of Ruby on the Parrot VM. This one is particularly interesting from a parsing perspective because it takes the Ruby grammar, not the Ruby grammar file, and reimplements it from scratch to build a PGE grammar. To my knowledge, this is the only time this has been done, because every other time they've taken the Ruby parse.y file and reused it or rewritten it in a certain way. At the same time, Microsoft is attempting to bring Ruby to the .NET framework, and they build something called Iron Ruby, which is a rewrite of parse.y and uses some parts of it to build their own parser. Finally, right before YARV is released, Ryan Davis comes back into our story and reintroduces a new parser called Ruby Parser, which is a gem that gets published, in which he takes the parse.y file from Ruby in similar fashion to all the other implementations, rewrites all of the actions in Ruby, and then passes it through the rack LALR parser generator. This gem is still around today and is used for the basis of a lot of projects, including a couple of security scanners, a lot of the developable tools that are listed here, and some documentation generators. Finally, we get to the YARV era. Ruby 1.9.0 is the introduction of YARV. It's a massive rewrite of the internals of Ruby. It's a switch from Yak to Bison. The Bison is kind of the spiritual successor, so that's not really a massive deal. Switching from a tree walk interpreter to a bytecode interpreter all of a sudden makes a lot of those projects that previously existed no longer function. Ripper, fortunately, is merged into the standard library. It's baked into the parse.y file as a form of a special comment that you can use to indicate which kind of actions are going to be dispatched at which time. Also introduced at this point are some new syntax that all of the implementations now need to deal with, including lambda literals and symbol hash keys, both of which were somewhat controversial at the time and somewhat controversial today, depending on the person that you ask. Apple at this point wants to get into the game with MacRuby, which is an LLVM port of Ruby using Objective-C. Because Objective-C is a superset of C, at this point they can mostly reuse parse.y, and that's what they do. Into 2009, we get Ruby 1.9.1. This is the first of the 1.9 series that is considered stable and is used for stable development and production use of Ruby. A couple of interesting syntax was introduced. The encoding pragma in Ruby 1.9, we get encoding as a first-class citizen. There's also the shorthand for calling a method with call, the call method itself. And positional arguments are now allowed after splat arguments. It's at this point that a couple of researchers at the University of Maryland College Park in the US create the Ruby intermediate language. This is one of the more interesting entries in this timeline because it's actually a re-implementation of the Ruby parser in OCaml, and it's used as a research tool for building type systems. And a whole bunch of other projects get built on top of this, including JRuby, the Ruby type checker, and Ruby Dust. And all of these things are used using this OCaml parser. Today, this research is still being done, but it's actually using the parser gem. Also at this time from the academic side of things is Laser, which is actually an undergraduate thesis by someone out of the US. It's a linter, it's a type system, it's a documentation generation system, it's a whole bunch of things. At the time, he was actually using regular expressions to parse Ruby, but then eventually switched to Ripper. At this point, we get Ruby 1.9.3, and this is a very important inflection point for Ruby because Ruby is now being standardized. The Japanese standards organization, the International Standard Organization are now documenting Ruby, and this kind of documentation, this kind of standardization is then used for other implementations. One of those implementations is Topaz, which is a re-implementation of Ruby targeting R Python. Similar to the other implementations of Ruby, they rewrite the parse.y grammar file, except in Python fashion, the rules are now decorators on those functions instead of the normal parse.y that you normally expect. It's at this point that we get to the Ruby 2.x series, and this is the Ruby we start to recognize. Very quickly, in Ruby 2.0, we start to get refinements, %i symbol lists, keyword arguments, all of these things that start to factor into modern Ruby. And it's at this point the parser gem is created. The parser gem is a very interesting published gem on Ruby gems today. It's got a well-documented parser API, a well-documented AST, and it's no wonder that it's captured a lot of the interest of a lot of developers out there. This is a list of all of these massive projects that are using this gem, and it's by no means a complete list, but some of the more interesting ones like Rubocop, Ruby Next, they're big projects that rely on this. And it's so well documented, and it has this community around it, and that's one of the reasons why I think personally it's favored over Ripper in a lot of ways. At this time, Oracle Labs is hosting Chris Seaton to fork JRuby, take it and port it to the Graal dynamic compiler, the Truffle AST interpreter, and Truffle Ruby at this point is born. Truffle Ruby at this point is the only implementation of Ruby that is up to date with Ruby syntax, which is a tough statement to hit because Ruby syntax is constantly changing and you're constantly trying to catch up. Quickly moving through, Ruby is now releasing every Christmas, and we start to get all kinds of new features, like required keyword arguments. Previously, they were always optional. Complex and rational were classes that already exist, but now we have literal syntax for it in the frozen string literal syntax. This is an interesting story. At the time, a lot of people were very interested in reducing string allocations, and so they introduced a new syntax that had an F as a suffix to strings. That ended up getting removed before Ruby 2.1 was released, and it was decided to make .freeze the string method optimized within the interpreter. Ruby 2.2 comes with a dynamic symbol hash keys. 2.3 introduces the frozen string literal pragma. Again, more work on reducing allocations. We have some here docs that will strip leading whitespace, and the lonely operator is introduced. Ruby 2.4 comes with more improvements to refinements, top-level return, multiple assignments and conditions. At this point, we get to the point where we're introducing TreeSitter. TreeSitter is an interesting parser generator library that doesn't truly have full compatibility with Ruby, but it's not necessarily meant to. It's used to power IDEs and other tools, and it actually underlies VS Code Ruby, which is the most popular language server to this day used with VS Code. Around this time, there's also a very interesting project created called typedruby, which is a type system, an incremental type system for Ruby written in Rust. The parser is written in C++, and they create the parser by taking the grammar from Ruby 2.4 and the lexer from the Ruby parser gem and creating its own parser. This parser is very well designed and ends up being vendored into the sorbet type checker and used for that as well. In Ruby 2.5, we get more improvements to refinements, rescue and ensure at the block level. 2.6 comes, and we get the introduction of RubyVM AbstractSyntaxTree. This is a very interesting addition, and it was actually added as a test case for another entirely unrelated feature. Unfortunately, people noticed and started using it. And now it's kind of in an odd space where it is being used, but it's marked as alpha software, even though it is functioning and likely to change. We also get deprecated flip-flop, which ends up getting undeprecated, endless ranges, and non-ASCII constant names. Ruby 2.7 introduces the largest amount of syntax that we have ever had in Ruby. It's a massive list, and it's a big ask for any other implementations of Ruby, and it's no wonder that only Truffle Ruby has really kept up with this entire list. Pattern matching is the only one I'm going to truly call out of this list, because that is an entire other talk's worth of syntax being introduced. At this point, we're getting up to the Ruby 3 era. We get a couple of interesting additions in Ruby 3.0. Keyword arguments were introduced in 2.0, but at this point, they're separated keyword arguments. They're not based on a hash, so they have their own semantics, and this has caused a lot of breakage, which got handled by deprecations and largely hasn't been too impactful. There's also single-line methods, the find pattern and pattern matching, a new pragma for ractors, and even more pattern matching. For the future, Ruby 3.1, what are we going to have? We don't know. At the moment, the only syntax being really proposed is the anonymous struct syntax. So what can we learn from all of this? For one, it's very difficult to keep up with core. Other implementations of Ruby have tried to, but as core constantly changes and the grammar file constantly changes, it's very difficult to keep up with every single individual feature. Every time syntax is introduced into Ruby, every single one of these projects that I've mentioned has to go and update itself, and then all of its dependents have to go and update themselves. So very small changes in syntax in the parse.y file can have very wide-reaching effects in the entire ecosystem. Finally, there's so much subtle logic in parse.y. Parse.y is a file that's going into Bison. Bison is a tool that is meant for generating parsers for context-free languages. The issue is very few languages are actually context-free. Ruby itself is a context-dependent language, so you have to implement all of this individual logic yourself. And so very, very subtle logic is encoded into parse.y, and it's very difficult to extend. So, what are our options? If we want a parse tree out of Ruby, we have to go to a couple of specific tools. Really, there are three. There's the parser gem. Tons of community adoption, very well documented. The only issue is it's not 100% compatible. Stuff may break. It's not always keeping up with core. The issue is it's not maintained by the core developers. It's not the first-class citizen. And when things change in parse.y, they constantly are trying to keep up. There's also RubyVM AbstractSyntaxTree, which there's an entire talk's worth of future about AbstractSyntaxTree, about what's going to happen with it. It's really still too early to tell if it's actually going to be used, and it's not implemented on any other implementations of Ruby. Finally, there's Ripper. It's built into the parser generator. It's well tested in core. It ships with Ruby. However, there's no documentation. There's really no way of understanding it short of digging into the C source code or digging into just running it and seeing what's going to happen. So if you really want a parse tree from Ruby, your options are something that's not kept up to 100% compatibility, something that's absolutely brand new, or something with no documentation. So solutions are tough to come by at this point, but we need to invest in something as a community. Finally, just as a final addendum, language servers were introduced by Microsoft when they introduced VS Code as a way of interacting with languages from a metadata perspective. And from Ruby's perspective, what do language servers look like? We have SolarGraph, which either uses the parser gem or RubyVM AST if it's available. This is probably one of the largest ones,
It has some support for Ruby internals, but not a lot. There's also an alpha version of a language server that uses Ripper. VS Code Ruby is probably the most popular, and it uses tree sitter under the hood. And finally, there's another alpha one called Yoda. So all of the information that I've talked to you about today is published on my website, kddnewton.com/parsingruby. You can go and look at the timeline. The moral of the story is we should invest in these tools. We should invest in the community, and we should invest in these things so that we can continue to build these great, powerful Ruby developer tools to go and build our production applications with. Thank you.